Ladies and gentlemen, good afternoon. Unfortunately, I cannot stay with you in person, but I like to share my thoughts about landscape planning and nature-based solutions and the therefore needed data that help to work on key aspects to climate resilience and also to mitigate climate change. The main focus will be the land use and as a very important factor against climate change. Agriculture and food system, from land use changes and food protection to packaging, transport, consumption, account to more than 40% of the global greenhouse gas emissions. Agriculture, in particular, the conventional practice of blowing, overuse of mineral fertilizers in meat production and food loss, as well as waste, contributes to the release of greenhouse gases such as carbon dioxide, methane, and nitrous oxide. Deforestation is another problem. I will not focus in detail on this, but we see if we have to tackle the problem, then we need also to talk about possibilities to keep soil, to mitigate the influence of climate change on physical structures. If we have a closer look to the 9 planetary boundaries, we see that biodiversity loss, land use change, and climate change having a very big influence that we can deal with proper and sound land management. We can have a closer look to the negative consequences of poor land management. If you look to the United Nations Convention to combat desertification or the United Nations Framework on Convention on Climate Change, as well as Convention on Biological Diversity, we can see that the regulating factor is the land management, because poor land management can decline the ecosystem services. We will have the habitat loss and change of species abundance. We have decreased mitigation and adaptive capacity, and we have the land degradation for reduced productivity and resilience. Sustainable land management encompasses the following tasks. So it's improving the soil quality and increasing resilience. We need to promote ecosystem services. We have to hold and reverse the loss of biodiversity, securing and restoring habitats of flora and fauna, and preventing climate change by keeping carbon dioxide within the soil and other things. And we need to adapt and mitigate the effects of climate change. This means geospatial data are required and needed, and they're building the frame for planning and implementing measures that helps to mitigate climate change and improving the resilience against climate change. I want to put my focus on flooding. The flooding will have threats to infrastructure, we will have threats to biodiversity, and we have an increasing carbon emission by soil loss, not to talk about other influence on polluting soil and water. So, as I mentioned before, we need to have reliable data to plan and implement our measures. I want to focus on the so-called Bavarian Atlas, in German Bayern Atlas, where you can have different data that can be tackling topics and that can be used for administrations as well as for private person. The data can be acquired, and there will be more reliable data also within different administrations. So we will talk about topics on the environment. We have the nature risk insight, and we have also the geobasis data that's used for getting the exact mapping data. So those data can also be acquired from institutions, and they can be also get more detailed for engineering offices and other administrations. I am focusing, as I said, on the topic of flooding. And we see here, for example, within this Bavarian Atlas, that we can find out different scenarios that we can put in about the flooding. So, for example, the areas that are designated as floodplains, what we can see here, that's for sure has consequences for planning of settlement areas, for land use plans, and also building zones. But we can see also how we can protect those areas by suitable measures. There is another topic in this. For example, we see the risk areas of these flooding zones that's given there directly. Another topic that's inside here is the biotope mapping. So we can see different biotope structures inside here. So as a planning base, they are protected partly, but we know the structure already, and we can also focus more on other protected areas, like for example, protected zones for birds, landscape protected areas, so we can come inside. So we have now the planning base for flooding events, and we have also the planning base for biodiversity that needs to be connected or fulfilled in a better structure. Another topic is the soil erosion. So in this map, you can see the mean soil erosion over many years, and it's indicated in pounds per hectare, and it's a high resolution map. So we can see the endangered regions, which are heavily used for agriculture, but which also prone to flooding. And both of them are starting that we have the problem of soil erosion, fostering the soil erosion, and therefore the carbon dioxide emission into the air. So it's very important to have it also very clearly georeferenced from the risk areas so that you can draw own conclusions on how to manage measures and also implement structures that help to mitigate climate change. If we have all the data, we need to come to the step that we have to work on the conflict and synergies. So we accept our planning area, we think about the protected assets, the amenity of the landscape. We can also add different topics like air and climate. We have the water and soil problems, cutting off with land use conflicts, and then we get objectives for the development. And finally, we can have a planning of the measures. So this is very important to have for all the same georeference data in a high resolution. Best would be for the whole country. That it's also possible maybe to find out automated problem areas and then come over with different measures. What have been the negative consequences of the poor land management? Here you can see a cadastral map of the year 1900 from Germany. So you can see that there are still a lot of retaining areas. We have not straightened creeks. The rivers have the possibility to go to the landscape, and the settlement is not touching the banks of the rivers. And we have now the problem that we have been straightening our water courses, that we building the houses till to the river banks. We restricted the natural flood areas. The landscape is very clear, so no structures that can hindering the free flow of the water. And with the industrial agriculture, we enhance the erosion and the drainage. And in addition, it comes the problem of the climate change, that we have increased number of heavy rains and thunderstorms, and heavy rains concern only small drainage areas. So we have a very high runoff. And we need to think how we can get it into the possibility that we have decentralized water storage areas that in a number of possible measures can help to mitigate the runoff, keep the water in the landscape, and getting the runoff after the main event it's gone. So here you see the possibility of totally five ground waves that keep the water back in small storage areas. And the retention volume is 180,000 cubic meter. It's helping to protect the nearby villages and a middle-sized city to go there on. And also you can combine it with an iteration, and the total length of the measure, it's 1.6 kilometer. So how it's done. So you see here on the right side the structure of the ground wave. We have a reduction facility, so only a certain desired amount it's coming through. That's normally the water leading capacity of the creek or the river. And if there's more water coming, it's restricted by the reduction facility. So we are able to store the water behind this. Here you can see the construction of the measure. In the landscape, you can see here the ground waves that should block the water. And here we have always the retention areas where the water can be blocked. So it's fitted to the landscape. And after the flooding event, we can see on the right side picture how it looks like when the water is coming through. So it's only a possibility of highlighting this. So what are challenges on political implications? We have a competition for land resources, so we need to set very clear priority where it's going to. So it needs, on the one hand, clear planning data, but also on the other hand, the georeference data to manage the modeling and the desired land use. We need an effective climate policy that focuses more on land management and land use. And soil is a crucial link between the loss of biodiversity and climate change and must therefore be at the center of the measures. So also one important point is restoration of degraded soils. That's also a very important topic in China. And we need a restoration of land and ecosystems that will contribute also to mitigate the climate change. And therefore, we have really the need for accessible data for modeling and planning, that it's needed for public purposes, but also can be used in private measures, for example, for exact building plans and topics. But we need to go also more further on this. We need a rising awareness of society. We need enabled integrated measures and actions. We have to coordinate the authorities and also try to stimulate them to get a share of the data and having them in the same access. We have effectively addressed the societal challenges that will coming up. It's also calling for urban and rural cooperation. We need interactions between the economy, society, and ecosystems. We need for seeking synergies across the different sectors. We have a risk identification and risk management beyond the intervention side. And generally, we need to have a net gain of biodiversity and ecosystem integrity. It must be economically viable and basing on inclusive, transparent, and empowering governance process that's also fostered from georeference data. We have to have equitability balance for trade-offs between achievement of primary goals and the continued provision of multiple benefit. Thank you very much.